Hi, thank you very much for having me today. I'm super excited to be here at AFWERX Fusion. I'm going to talk with you about solutions in 3D. So let's get started. Like I said, my name is Catherine. I'm representing Black Opal LLC, Black Opal Rapid Prototyping Solutions. So some of you may know me as the former director of the Travis Air Force Base Phoenix Spark Innovation Lab. I was an instructor boom operator for 10 years, and when I PCS'd to Travis Air Force Base, I was picked up and asked to help set up a makerspace. It was the Air Force's first grassroots innovation hub where airmen could get together, share ideas, and build upon those ideas. It was even made before AFWERX existed. While there, I taught airmen how to use 3D printers. I taught them how to 3D model, how to code, how to solder. They went back to their units and took these ideas and tools with them and started identifying problems and saying, you know what, I can come up with a solution in our makerspace on the base here. And they brought them back. Our program grew rapidly. We started getting an enormous amount of attention. We had tons of ideas coming out of this program. Some of the ideas I was involved with, you see on the screen here, such as the C5 seat. All I did was go to a unit and talk with the troops about what problems are you seeing? Invited them back to our makerspace where we were drawing on whiteboards, went out to the flight line. Before we knew it, we had engineers visiting the base and helping us design a new seat for C5 loadmasters to sit on so they can scan outside the window. So let's talk a little bit about what the base of the future looks like with 3D technology. So just imagine for a minute that instead of having supply chains in warehouses full of equipment, you go to a supply warehouse and instead you say, I need a part. In a couple of hours, it's manufactured on the spot. Or let's say for aircraft maintenance. Typically, if an aircraft is broke off station, it might be stuck for a while, waiting for a part that has to be flown across the world on another airframe, keeping the aircraft down and costing the Air Force countless dollars. Well, what if instead the aircraft calls that they're broke while inbound to the base and aircraft maintenance is already 3D printing the part before the aircraft lands? And there's somebody on site to certify the part for flight before the aircraft lands. That gets the aircraft back up in the air and mission ready and mission capable. Imagine also remote bases and bases in austere environments. Currently, you have to set up with local nationals to create buildings and infrastructure and set telephone lines and internet lines and such. Well, what if we cut part of that out? There are companies out there right now 3D printing entire buildings with large rigs with cement in as little as 2 days. What if we just brought the equipment with us? Cut costs, cut time, we're doing it ourselves. Imagine medical units. Right now, you can 3D print nasopharyngeal swabs to test for COVID-19. There are tons of applications to include dental molds, dental trays, and other replacement components that medical units constantly go through. Imagine you had an office where you just need more parts and someone's there cranking them out on demand. All of this will greatly improve our warfighting capability, save time, and save money. Let's talk about some of the gaps. What's keeping us from achieving this dream? First of all, the talent. The reality is we just don't have the people with the skills that we need to do these things. Take, for example, a simple 3D printer. If I purchase a 3D printer for a unit, nobody knows how to use the printer, nobody knows how to load the filament plastic, and nobody knows how to 3D model, everyone's going to stand around looking at this printer wondering why it's not solving everybody's problems. It's just like buying an airplane and having no pilot. The airplane's not going to fly itself. We need to have the right people. We need to have training programs. We need to identify these people, and we need to give them follow-on training, and we also need to retain them, because right now it takes an average of 6 months to train somebody up for a basic skill set to be able to 3D model and 3D print. which is also the average amount of time that a unit is willing to loan an airman to an innovation program. So by the time they've got a basic skill set, they're gone. So we need to get the right people for the right job in order to make this dream a reality. We need the right equipment. I've seen military bases buying 5 of the same printer, thinking they're going to solve 5 times as many problems. And they got the wrong printer. We need to know what our problem is and identify the right equipment to solve that problem. Application. Because of a lack of knowledge of what 3D printing technology, additive and subtractive manufacturing technology can bring to the Air Force, there's confusion about how it can be applied, how it can solve problems, what can it do for me? So we need to make sure that the application is very clear. What are we allowed to be doing with this? We need to be updating our regulations to reflect what is and isn't allowed as technologies advance. Since we're talking about regulations, we know the Air Force has quite a few of them. And right now, they're very restrictive in regards to innovating using additive and subtractive manufacturing technologies. That's keeping us from reaching our vision of utilizing these technologies to solve problems. What we need is a central location that can rapidly flex with changing environment and technology, so that as people come up with ideas and come up with solutions and are creating additive and subtractive manufacturing solutions, this organization can say, this is approved for flight, this is approved for use, this is now an approved alternative for this component. Additionally, we need AFSCs and SCIs that identify people with these skill sets. These people are out there in the Air Force, and we need to know who they are. The AFSCs, if we have them, we can now train people to be 3D modelers, to be 3D printing specialists. That means they can work full time. We don't lose them in 6 months. If they have an SCI, we can pull them for duty and use them as needed. At the moment, we don't have that. The base of the future will. Lack of information. People don't know what they don't know. People have no idea that these solutions are out there utilizing this technology. When I directed the Phoenix Spark Innovation Lab, people would come in, I would teach them the equipment, they would go back to their unit, and within days, I would have even more people coming in saying, hey, this equipment, can we make this thing? It's gonna solve my problem. The more we educate people, the more successful we're going to be. Revolution. It's going to take a big overhaul in Air Force policy to adapt to the changing technologies of 3D printing, additive and subtractive manufacturing. It's going to start from the bottom up. People need to be saying, I need this. This is going to solve my problems. It's going to save my troops time and money. And at the top, it needs to come down. You know what? You need it. We're going to support you and you can do it. So let's talk about some 3D technology applications. So 3D technology has the ability to create parts and components out of nothing. 3D technology is this rare instance where you can combine the digital space to the physical space. So I can take something that's on my computer screen and make it a reality. That's something unheard of years ago. We can use it to increase our combat effectiveness by creating things on the spot. Imagine having a virtual combat field and you put on VR goggles and you're looking at it in real time, just moving your head around, and it's been 3D modeled with the trees and where the troops are and where the equipment is and everything. Everything can be rendered. Well, hey, let's take that a step further. Why not take a CNC machine and a big block of wood and create that and put it on a table? There's all sorts of capabilities that people haven't considered for additive and subtractive manufacturing technologies. There are a couple different applications. Some of the important ones I'm going to highlight, as it's been brought up previously, is that we have aging fleets. We have aging equipment. We have manufacturers who aren't making the replacement parts that we need for our equipment. Why don't we just make it ourselves? And we can do that. Today, that can happen. We also have problems with getting things to austere environments and remote bases. Right now, if I need a couple of components, like simply some doorknobs and some hinges, and I'm in a remote location, we have to get the word out. We have to go through contracting acquisitions. We have to somehow get on a plane and wait for the plane to get there. Why can't I just make it on the spot as I need it? There are multiple different materials that are being used for additive and subtractive manufacturing right now. Formlabs has now developed a ceramic resin that you can sand down or paint, which is very cool. And now the technology has advanced to the point where we can have custom materials made. If you need it a little bit flexible, if you need it to be flame resistant, if you need it to be easily breakable, all of these things can be custom made for you. Let's talk about a real world example. So that's actually a picture of me wearing aircrew AERPS gear, covered in multiple layers of plastic and rubber. Well, when you're covered in plastic and rubber, you do need to breathe, and there's a blower motor that supplies air. And part of this ensemble has little tubes that blow air where your eyes are for the mask so that it doesn't fog up. Unfortunately, it was designed so that where the tubes connect to the mask has little plastic pieces called Plenum tubes that break away. The reason they break away is in emergency, if you had to get this off because your blower motor dies or something, you rip a strap at the neck to open a hole in the mask to get air to you. And they want the clips to break away to release the tubes. Unfortunately, they break away a little too well. They are constantly breaking. You fold them up and pack them and put them away, they break. You put it on, they break. You take the suit off, they break. They are constantly breaking. There are teams at every Air Force base that work full-time to repair and replace these Plenum tubes. They cost $12 a piece. We go through thousands a year. And the repair time is average of 24 hours. They have to drill with a Dremel. They have to get the epoxy and drill it off the rubber. They have to prep the surface. They have to clamp it, mix epoxy, set it. It's a pain. And these folks are doing it full-time every day just to keep us going. Solution? Black Opal just filed and now has a patent pending on an improved Plenum tube. It's called the Black Opal Plenum tube. It's heat resistant. It gives a little bit of flex before it fails. It won't break unless intentionally forced to. And it is a direct one-for-one replacement to the original. This kind of thing was 3D modeled and 3D printed using additive manufacturing with resin. This is a great solution for the Air Force, saving time, money, and manpower. It's very exciting. Little things like this, a tiny piece of plastic, saving the Air Force tons of money and time and manpower. And these kinds of things can be manufactured on site versus trying to acquire them from a manufacturer. I want to say thank you to AFWERX for having me come here today and starting session 2 about a super exciting topic, 3D modeling, 3D printing, additive and subtractive manufacturing. I'd like to invite you, if you'd like to continue this conversation, to reach out to me directly, Catherine@blackopal.tech, or visit my website, www.blackopal.tech. Thank you and enjoy the conference.